I'm traveling this week, so for the other class, they're going to have this pre-recording, but you guys get me in person this week. So. Yeah, so ask away questions. And I'll try to anticipate the other class's questions too. But yeah, let's go ahead and dive into it. So today for a little warm-up here, so some of you folks, again, know that I'm sort of a systems-y graphics person or like that aspect of things. Again, folks, maybe you met me for 5008. But there's this book, somewhat famous in the, systems, operating system land called The Cathedral and the Bazaar. And it's basically written about just building a Linux operating system. And some of the kernel they call, which is the core component of that. And it has several, software engineering lessons. So I'm going to just click on one, or click on the wiki and show you the list here. And they're specifically for, creating good open source software. But I think these are applicable to, just building good software in general. So I don't know if anybody went through this list, but did anything from the list speak to anybody or anything that they see on just this first page that might be important for software engineering? What do folks think? Release early, release often. That's what I heard, yeah. Is that on here? Which number is that? 7, okay, yeah. Yeah, and we're going to talk a little bit about that today. Any of these other ones? Yeah, I was just looking at 9. Smart data structures and dumb code works a lot better than the other way around.
I like number 8 and 10.
So, good abstraction, number 9. 8, given a large enough beta tester and co-developer base, almost every problem will be characterized quickly and the fix obvious to someone. Yeah, if you have enough folks. So again, big open source project. So number 10. If you treat your beta testers as if they're your most valuable resource, they will respond to becoming your most valuable resource. Yeah, that's a really good life lesson too, I think. Value everybody. I always tell people the most important people, at least for me, is usually the admins that I work with, because they're the ones who know every piece of knowledge here, get a lot of stuff done behind the scenes. So yeah, treat everybody on the stack as if they're important. Let's just go through this list here a little bit more. These are 17. A security system is only as secure as its secret. Beware of pseudo-secrets. Yeah. I don't know where the right exact place to bring it up, because I don't know if it was a security issue yet, but how many people tried to log into Facebook yesterday?
At first I thought, I was like, what's going on? Like, did I just lose my password?
Yeah.
And I'm like, oh no, it's actually down.
Right, yeah, Facebook, WhatsApp, Instagram, everything. So, whether that was a security problem or something just wrong in their process for how they update, I feel like there's some wisdom to be obtained here. So I thought that was kind of interesting, and I'll figure out some way to weave it in once we figure out the problem of, processes, because that's what we're going to talk about today. But I thought that was funny. I was messaging my buddy to meet for lunch here, or coworker, and I just couldn't reach him. I was like, what's going on? Facebook's actually down. And I wonder how much money it costs them, too, to be down. Them and, all the businesses that rely on Facebook. So, but anyway, so we've got some of these rules here. I highlighted one that I thought was, that spoke to me most, but, to solve an interesting problem, start by finding a problem that's interesting to you. And that's something that's always sort of guided me, one of the reasons I've sort of gone the sort of research academic route, and in industry as well. I always look for problems that are interesting to me to solve, and then you inevitably get interested, right? And you'll sort of have your own individual path, whatever you decide. Maybe you're more interested in web or graphics or systems or hardware or whatever, and then you'll find interesting problems because, again, they're interesting to you. All right, so let's see. Just want to verify I'm recording. We are 4 minutes in, so. All right, but I want to get us organized here and do a little scrum here. And how many folks have heard the phrase scrum before? Okay, so a decent portion. So of the folks who have heard of it, do you know where the term comes from? Rugby. I heard a bunch of rugby folks. Yeah, so here it is. This is a rugby scrum. So somebody, some computer scientist or software engineer coined that term or borrowed it from rugby. But a scrum, and basically the idea is you have these folks here who are in a scrum, but they're locked together, trying to push the ball forward or whatever in a sport to score more points. So it's sort of that's the idea. That's where the word came from. Let's see, and they coined it in 1986. Again, the idea is working together as a unit, sort of self-organizing in the way that these folks, on a field might sort of self-organize to, block where the opponent is or whatever, is going to be more efficient over time if you let these folks give them some ability to, again, self-organize. Okay, so we're going to do, for the rest of our semester, a scrum to start the class. Because we are the software engineering class, so we should do that. And don't worry, it doesn't take too long, and there's a lot of ways to do it. But we're going to have our daily scrum, and how it works is, we've actually been doing this for the most part in every one of my classes, but but we want to reflect on what we've done, what we're going to do today, and what we're going to do in the past, essentially. Give us some sort of framework, some way to organize and move forward. Okay, so here's an example scrum that you might do, and this is pretty similar to what I did, where we'd have a standing meeting. So maybe you've done this with some employer or group project, whatever, or in this class, which we'll do. But everybody stands up. Often somebody literally has a timer, and they'll time you to get 1 minute to talk about what you did yesterday to achieve some goal, what you need to do today, and then if anything's blocking you from making progress. Okay. So I'm going to ask you if, for example, CMake is blocking you or whatever. We'll talk about that. So these are the questions that we'll address here. Okay, so who participates in the Scrum? Well, all of us, and typically we have different names for the folks. So you have some product owner, maybe that's the manager, somebody overseeing a larger unit, and they're usually the ones, you might just call them your boss, but they're overseeing, trying to figure out what's important, usually from a business value, what's going to earn money, build the tool faster, and just, there might be a million interesting things to focus on in software engineering, but they're going to say, these are the 3 most important things to, push us forward and make the client happy, okay? Because they're ultimately paying the bills. So that's the product owner. Then you have a Scrum Master, and there's someone, again, they can be someone sort of managerial, maybe they're also technical, they could also be a software engineer, and their job is usually to do whatever it needs to be done to make the team successful. Okay, so again, sometimes they're just sort of running the meeting, keeping things moving, to say. Sometimes they are tackling problems, sometimes they're acquiring resources or whatever. And of course, their main role is to run the meeting here. And then you have the Scrum development team, and that's typically the engineers. Most all places I've worked at, this team has been, roughly 5 to 7 people. So PlayStation, we're sort of organized like that, Intel, and then you have a manager on top of those 7 people, and then a team of a few managers, and then someone on top, roughly in that organization. Doesn't always have to be, but that's roughly how it works out. So just to, for our class, give some concrete, who are these people? I'm the product owner. I guess I'm going to tell you, what's sort of important and what we're working on next in the terms of assignments and labs. But that'll transition a little bit, as we get into project mode. But then the Scrum Masters, those are sort of the TAs. And they are technical, but they're trying to make you folks successful, answering your questions, moving things along, and so on. And then you guys are the development teams. You're the engineers and the heart here that's going to get things done. Okay. So to start our Scrum, we'll start off with what we did yesterday here, or last week for us in our Scrum. but we reviewed some object-oriented programming. So if you remember, we kind of did this deep dive. It was a pretty technical day, diving into C++, learning about these special member functions. We reviewed copy constructor, copy assignment operator, destructor, constructor, and the reason that we have to write those is because, well, we have to figure out how do we copy things. And there's a shallow copy that we get for free, and then the deep copy. And we sort of learn that with a deep copy, where you have pointers and these kind of things, you have to make a true copy, reallocate memory, copy elements one at a time. So we learned a little bit about that. And there's sort of a philosophy with that, RAII. Does anyone remember the what that acronym stands for? It's kind of a nasty one.
Resource acquisition.
Yeah, don't worry, it'll never be on the test, but you might want to remember RAII in the sense that typically it means when you create an object, so in your constructor or your copy constructor, that's where you want to do your memory allocation, and your destructor is where you delete things, just to make life easy for you. Because if you're allocating memory and all sorts of other member functions, well, how do you sort of keep track of that in your copy constructor? It's a lot harder, okay? And then we spent the second half of the class on design patterns, introducing them and sort of doing a walkthrough, this screensaver company. We started with the singleton, which is what folks worked on in the lab. That also introduced you to just some technical parts of C++, what static was, this idea that sort of preserves or creates an, well, depending on the context, it initializes a value once and only once, or a member function that's shared amongst classes. So we had a few uses there. With the singleton, we also saw we could hide constructors or copy constructors if we don't want to make copies. So some ideas there. And then we talked about the adapter pattern, which was a structural pattern, figuring out how things can work together. And then finally, the iterator, a behavioral pattern. I try to get you to buy into the argument that we like iterators in general. Okay, so that's what we did yesterday. I'm probably over a minute on that, but that's what we did. So now I'll ask you folks for any questions regarding stuff that we worked on in the last week. Maybe on the lab or things. Okay. All right. So then the Scrum Master will move us along. So what we're going to do today, well, your lab 3, that'll be due shortly, next 2 days or so, Thursdays. Lab 4 is also out, so we'll talk about that at the end of the class. It's going to be talking about some of the software development lifecycle stuff we're going to work on today. Assignment 3 will also be out sometime after class, whenever I get home, basically. So, but that's when I have it, so midnight-ish or whatever. I am out of town. That's relevant for the Thursday section, so they'll have this recording. And then today, otherwise, we're going to talk about software development lifecycle. So not as a deep dive. In fact, probably no C++ or anything today, unless folks have questions, but just on process. Because we are gearing up towards our final project being released in the next about 3 weeks or so. All right, so the last part before we can do what we're going to do today is what's blocking folks. Anything that they're struggling with or foresee. The other part is what do you foresee might block you, and the Scrum Master or product owner can try to alleviate. Yes.
Trying to make sure all my files are for the API are coordinated with the bits and software wise.
Yeah, coordinating everything. Is this from a sort of project management, just organizing, like for the mini paints, or?
Yeah, when I was doing mini paints, it seemed like some things were working with one another, and then some things weren't working with another. Such as after installing everything, I recognized, I had a 32-bit here, but then I have a 64-bit installed somewhere else.
Oh, I see. Yeah. So it's not some data types. Okay, so it's something that's blocking. Just to recap for everybody, is sort of debugging, maybe, or error handling. We're going to talk about that next week, which hopefully will give some insights. It's going to be more of a crash course into GDB and sort of bug finding and sort of error proofing your code, making it airtight. So maybe that'll help. I mean, it should help something. And even if you don't want to, for the next week, we're going to talk about GDB. You can use CLine or whatever debugger you want, but we'll have some debugging techniques. Other things, blocking folks. So hopefully you'll be unblocked in a week, if that helps. I know CMake is high on the list for some folks, maybe getting that organized with these things and working on a little. It might come out in the form of a video. I did make a Piazza post on CMake, and I'll try to do some more write-up on it. Yeah. Oh, did you have? No. Oh, okay. Yeah.
I was just gonna say like Vector 2i, I had a problem also with it, like trying to like release memory from my computer, because it seemed like it crashed out of the range of a vector the first time, but then when you try to rerun it, it would go 3 times and then crash immediately every single time after.
Interesting. So we're really, this is a good point to just show where we're at. So the comment was about Vector 2i, so some of the SFML data types, so getting familiar with the API, some things crashing out of range. Let me just bring up where we're at here. Because these all sound like testing and debugging things here. So 5 and 6. So yeah, I can't unblock you. Well, we can in office hours, but not immediately. We'll talk about some debugging tools so you can see where and when you jump out of range. So again, GDB, feel free to watch some of the YouTube stuff I've posted already, but we'll have something dedicated to that. And then how to sort of test so we have some confidence that before or during our program while it's running, we can handle errors like this. Yeah. Other things, blocking, was there a comment in the back?
Yeah, maybe this ends up being more debugging as well, but since there's constructors and destructors, and we're using like third-party types, I started to get confused on when memory is actually being like destroyed. Because you have delete, and you're assuming like, okay, is the third party taking care of this? Like, maybe it should be once it leaves whatever appropriate scope. But when is that happening? Like when, you know, like, sometimes it seems like the types, especially if they're singletons, like maybe they are, maybe they aren't. You know, and I just never know. Because it doesn't say like this is a singleton, you know, there's only one instance. Because we're using a lot of create, like .create. You know?
Yeah.
So where's the memory? I don't know.
This is a good question. I think the comment, to summarize it, is about how much do we trust SFML that they're doing their job on their constructors, destructors, and building things. Does it cause memory issues in our code? And sort of, you know, do we trust the API? Right now, we're sort of looking at it as a black box, and we're just going to assume that's not our problem, basically, if it crashes, which is fine. We're going to assume, I mean, this is actually one of the big topics in software engineering, right? Following sort of ownership, we would say, like where the memory was allocated is a third party, maybe it's a different programming language even. So I think we're going to get to the point where we're going to have our C++ code work with Python code, and then when we think about, well, is Python making memory or C++? So we'll have to deal with this issue of ownership.
And maybe more specifically, I never know when I'm supposed to allocate memory. I guess because I'm so used to doing it in C with everything.
Yeah.
That now you go to like these types that have constructors, but it's not completely Java, so it's not like you can kind of just ignore it.
Yeah. So if you're allocating, say, let me give just a concrete example. Here, I don't know, SFML example, something like this. And you're implementing one of these types here, right, vector 2i. You could still make an array of this other type here, and then you're allocating, you know, new, SF, vector 2i, you know, 100 of these or whatever. And then you're responsible for deleting the type. Now, what their constructor does and all these sort of internals of vector 2i, which I'm guessing is just, you know, 2 integers, x and y or something, you know, we have to trust them that they'll manage that memory if there's anything behind the scenes. But so our responsibility here is just for us to call, you know, delete array, and then we're done.
So it seems basically if you don't have a new keyword that you're writing, you don't need to delete it.
Correct. Yep.
Okay.
Yeah. So if I rewrite this, let me rewrite this another way here. Array like this, and 100 of them like this. Right. This is just stack allocated, and again, there might be a constructor behind the scenes there, but it'll get called and do whatever it needs to. Right when we leave scope.
Cool.
Yeah. Yeah.
Thank you.
Yep, you're welcome. Yeah. Other questions, things blocking, folks? These are good questions because we're trying to start thinking about SFML. That's going to be our main sort of third-party library. Trust is sort of an issue with other APIs, right? If they have bugs, who's supposed to fix them? We do have the source code, which is one reason why we're using the library, so that's a good thing. And we'll eventually be able to see it too, because we'll be able to compile it and so on. Yeah.
File organization, so like dependencies and where, like, because some of the times I put stuff like straight in my C drive.
Yeah.
So.
Well, let me
Like
address this. So this one might get fully addressed tonight with the CMake. So in lecture, this module 4, I'm going to put it, and maybe there'll be a video or something associated with it. Again, it just depends on when I go to bed tonight or early tomorrow. I mean, it will get done tonight or tomorrow. But what I want to show you, maybe this will be of interest, because I think this is something blocking folks. But so structurally, right, we have something. Whoops, there's too much stuff here. A build directory where our binaries go, maybe a source directory, maybe an include for any header files, and then we've been given or learning about this CMake list, this build tool. Again, that I'm trying to convince folks that it's going to make their life easier when they start working on teams. So anyway, if I want to use this CMake list file here, I can run CMake, and then I'm looking for the directory up where that CMake list.txt is. Okay, then I hit enter, and it's going to give me a bunch of stuff here. This is the kind of stuff I want to explain in the video, but basically it's building a make file for me. So then now within this build directory, I can just type in make, and that's it. Or it's generating a Xcode project, or a C-line project, or a code blocks, whatever IDE you want, right? So you can just hit run from it, right? That's the idea. For me, I just like make files, so I can hit make, and you'll notice it does a bunch of stuff here. Now the question was about organization and dependencies. Okay, so a dependency that we have for our mini paint is the SFML library. Okay, we need that to do our painting and drawing. So within this build project, in the CMake file, basically creates a directory called _deps for dependencies. What this particular CMake file is going to do is download from the SFML GitHub repository, build the source code from scratch, and then put the libraries in here. Okay, so that's just sort of an organization thing that we can do. Most folks, if you've otherwise been working with SFML, you've used sudo apt-get and done it on Linux or on the VirtualBox. On Mac, a lot of people brew install. Windows folks have downloaded the library files and figured out where they are. Organization-wise, this will hopefully be optimal, and that way when you distribute your project to somebody, they have everything. Okay, we'll talk a little bit more about that in the final project.
So you always have this depth folder in the software release that you give to the customer?
In this one, yeah, if you structure it this way, you're giving them all your source code. So I won't say always. For us, we don't care. It's open source.
For example, you are some company who is developing a game for somebody, right? You might not want to give them your source code, but you want your code to work with the dependency. So how does they compile into the thing that you release?
Yeah. So the comment was about your game company. You don't want to give them, all your source code and all the stuff that's in here. So what do you do, especially if you have different platforms? Well, then me as the product owner, I would compile the libraries on my sort of machines and say, okay, here's the Mac libraries, the Linux ones, the Windows, and so on, and just distribute the libraries, the compiled files.
I'm kind of wondering, like, for our particular project, we're using SFML, right?
Yep.
So as the project will grow, there will be like a lot more libraries that we use in a third party. And like, how do we actually like package them together when we release the software so that it actually works on the system?
Yeah, to get to the point where we have a little installer. So
Yeah.
yeah. So the question is about, okay, we have all these libraries. How do we package it up? How do people actually build software and have a little installer that you click on and it installs? We will get to that. That one I'll leave on a cliffhanger. That one's not blocking us yet. So Scrum Master, I'll say, don't worry about it. We'll get there. Other questions? Other things immediately blocking folks? And this will be the first semester I actually get to building the installer, because it's very satisfying to give it to, like, one of your friends or something and run software. Yeah.
I was going to ask, like, is there any assumptions that we should make or know about for data removal and cleaning?
So assumptions about data removal and cleaning for the installation and those kind of things.
More like what our program should leave behind and what should not be left behind after it runs maybe.
We'll talk a little bit about what should be left behind. Ideally, nothing when you do an uninstall. Yeah. That'll be the goal. The installers will help us with that, right? It's not polite if has anyone ever run an uninstaller and then they look and then half the files are there, or you look in your Windows registry and it's all messed up. This happens. So we're going to be polite. We're going to try to do things properly.
Right.
Yeah. Oh.
One of the things that I think is kind of confusing to me is like when to kind of go for classes and objects and when to just stick for functions normally. Like usually when we work with Java, we always have classes for every other thing, and then there are these objects that we are working with, like to kind of encapsulate that. But when you come to C++, like what is the sort of modularity that we actually go for the classes and not have simple functions for the other one?
Yeah, so this is a question about design. When do I use classes versus just functions?
For example, this mini paint thing that we did, right?
Yep.
There was a very straightforward script that we can write, and then there could be a complex version of creating object for a board and then using it.
Yeah, right. So even for mini paint, right, we can get away with just having a few functions. You just have one window that we draw on. What we're gonna find out, we're gonna find this out. Assignment 4 for sure, but a little bit of assignment 3 is we're gonna want objects. We're sort of gonna want to prefer objects. It's gonna help us test a little bit better. That's gonna help us with our patterns. But the idea is if you think you might need more than one of something, right, an instance, and sometimes that means literally in your program, or sometimes that just means, hey, if you're doing testing or unit tests, it might be helpful to have 2 windows or something and run a separate test suite on each of them. We can prefer classes. If you just have little free functions like computing the sine or the cosine or the tangent, these kind of free functions, those probably don't need to be wrapped up in a class, right? There's no state that needs to be maintained. There's no sort of attributes that would make it different than another instance of the sine function. So you can kind of be guided by that. Those would sort of be my guidelines. If you need more than one, and if you could have 2 objects. Again, we use objects sort of like in the real world. Like person, different people would have different attributes. Makes sense? Class versus functions. Yeah, because as we learned last time, C++ multi-paradigms, we have to sort of choose. We're going to prefer or lean into object-oriented programming for our C++ stuff. Not that we have to, but it'll make sense.
So if we consider the assignment, right, so we need multiple colors for the background. So it might be a good idea to go for the objects there and then have the objects loaded.
But yeah, potentially. I would say so. Yeah. I'm trying to think. I think in assignment 3 I'm going to push you towards objects no matter what. So yeah. Assignment 2, if we're getting mini paint, getting familiar with SFML, just how to change some things, goal achieved for that. Yep, however you can get it done. All right. Alrighty, let me move us forward. If anything's blocking, we'll handle after other issues. But Today I want to talk about the software development lifecycle. And just thinking about this, this little exercise that we went through, what's blocking. This is actually sort of the first, one of the first things we would think about in the software development lifecycle, right? Doing some planning. So asking about these questions. How should I design this? Is this library going to be a problem? Are there dependencies that we need to worry about, right? This is all sort of planning. You guys are looking into the future, right, and asking these questions. So that's all part of our software development lifecycle, okay? Because at the end of the day, our goal is to build some software, build some sort of product, something that someone can use. But in order to just build the end product, right, we need to have some sort of sub-goals usually along the way, some milestones. And we can't just build software, we have to make sure it's actually what the client wanted too. So there have to be some sort of, check boxes. And we can't take forever. We can't, we don't have 10 years to build our project. We'll have a few weeks. And ideally too, you're minimizing things like risk. So sometimes that means financially, is your startup going to go bankrupt? Are you going to run out of money because you have too many features or hired too many engineers or too few, those kind of things. And then you have other things, of course, security, privacy, some of these issues. So like everything else, having a process helps, right? If you've ever written an essay, usually your English literature or whoever, literature teacher taught you, hey, when you're going to write a story or something, make an outline first. And at least if you're like me, for a long time I grumbled and I was just like, nah, it's a waste of time, I'm just going to dive in. But an outline, helps you organize your thoughts and probably get a better product most of the time. So I do want to, with that, in mind, have this sort of honest conversation about folks and see if their process, if it looks something like this, because sometimes this is how mine looks. You got to develop some software, you just dive in. Start writing some code. And, that's fun to do for a while. But that has a name to it, that sort of strategy. We call that the code and fix strategy. Right? We're all guilty of this. Sometimes it's just logistically, sometimes it's, logistically just what works, but it has a name, the code and fix strategy. Or again, you have really no plan, you just start writing some code. And that's probably how we started off in the 50s, right? We're writing small software. But I don't want to even blame, the 50s. There were probably people following processes and, there are engineers there. So you just start off by building the first version, then you just modify it until the client is satisfied with it, whether that's you or whoever you're delivering the software to. Let them operate or use the software, and then you say, well, this, whether it was a big project or just some prototype, then you just use it until you're done with it, right? In fact, that's how a lot of homework assignments kind of operate, right? You've got 1 week to implement Minipaint, so you code it up, and then, it's done with, right? You don't see it again. We'll see it again, because this is software engineering, but, so again, it doesn't necessarily make it wrong, but if I apply this in the wrong situation, then we could have a disaster, right? And I'm just going to keep picking on Facebook today. I don't know what the truth is. But I'm going to blame them. I'm going to say they didn't think about their process. Some network engineer was just, hacking away and pushed a piece of code up. At scale, a very big company, this can break things. So again, no methodology. Again, so always remember code and fix with this one here. But yeah, what do folks think? I've kind of given some thoughts about this. Pros and cons of this strategy. If you could sort of summarize, maybe a pro or a con. Yeah.
It's usually pretty okay. Sometimes with like a short-term thing, such as a production issue.
Yeah, so maybe a short-term thing, it's fine. If it's quickly fixing a production issue, maybe it's fine. Yeah.
In my experience, the solutions you create with the strategy aren't very scalable.
Yeah.
It's hard to build off them, but I will say that doing this will allow you to discover like problems that you will have eventually, even if you did do it the right way,
Yeah.
faster, I think. So
Okay.
it's right sometimes.
Yeah, so there is some merit. As you said, there's almost a discovery phase in this too, when you're sort of just rather than doing nothing, you have to try something, and then maybe you find what the problems are later and can kind of plan around those.
Yeah.
So we're going to see how this sort of evolves. We'll have another name for that, prototyping. But yeah, that hits the spirit of this, certainly. Yeah. Yeah.
I was just gonna say it's like the fastest and cheapest way to do prototyping.
Yep.
Just like get something to work to prove it can, and then figure something out later.
Yeah.
For scaling or anything else.
Has anyone heard the term MVP in terms of software development? This is part of the prototyping strategy, but you can think of this. MVP stands for minimum viable product. Just get the smallest thing out that works. You know, if you're going to showcase this to, say, an investor, right? It would be better if you just had something that worked and they could see and mess around with, versus nothing, right? And sometimes you just do this as part of the process. Okay, MVP is really part of the prototyping stage, but we could apply it here. Right, so I think we've kind of hit on some of these, the pros, little, no overhead, small projects is probably fine. And again, as folks mentioned, prototyping. The cons, when you just jump into it, again, you can't really measure the progress. There's no checklist to say, oh, I implemented this feature or this. I mean, maybe you're keeping that in your head somewhere, but you were just sort of building stuff as you went along. So do you know when you're finished? Maybe, but maybe if you've done something a bunch of times, you have an idea. But it's hard to know or foresee what the risks could be. And as mentioned, if there are during this discovery phase faults that you find, you might just have to restart and throw everything away.
Does
Maybe.
anyone ever do that then? Does anyone
Yeah.
ever throw away a prototype?
I mean, depends, yeah.
There you go.
The most recent consulting work that I've done, our role actually was to be the sort of risk-taking team. So companies that are big and have their process, they'll hire a consultant or a few of us, send them a project and say, hey, can you make this work? And once we prove that it works, that's fine. They'll either take it and run with it, or they'll throw it away and say, okay, that is possible, which is kind of interesting. MITRE, has anyone heard of that company? That they are local to Massachusetts. I had to remember, I live in Rhode Island, I had to remember where I was, but they're local to Massachusetts. They're known for taking big government contracts. If you work as an engineer there, you kind of work on a project for 6 months as sort of an R&D person. So some folks might like that. I actually like the style of just throwing it away eventually, because then I don't have to worry about maintaining it for years and years. So it's kind of interesting. So you can use this knowledge to think about what type of place you want to work at. Somewhere that maintains something forever. Maybe it's good or bad. I don't know. But with other sort of pros and cons, collaboration can become hard, in the sense that, if Mike's just hacking away, not talking to anybody about what his game plan is, it's just whatever's in my head, whatever my vision is, right? Yeah.
I was just gonna say, this is also probably a lot better than where if you're working on two developers with no one else really.
Oh yeah. So I'll probably only work with only developers, maybe.
Yeah, because like if you work in a bank, don't know all the business people you have to work with, so you have literally no idea what to read.
Yeah. So the comment is, right? If you're working at a bank and you're not keeping the other, business or finance people or people thinking about other, this next point, separation of concerns, right? The bankers are maybe thinking about privacy and accuracy. The coders are just thinking about getting it done. The financial analysts are thinking about some other feature they want, So this makes it really hard to communicate. Yeah. Yeah.
It seems like this, well, maybe I guess I don't really understand it, so this is just my perception of it. But agile as a product development, philosophy.
Yeah.
It seems like it's all code and fix. When you think about, but it seems like you're always trying to go to the next thing or maybe not document things or maybe not till the end, but I don't know, just perception.
Yeah, let's hold on to Agile, because we'll get to that. Because we're going to see there is sort of a evolution. I'm going to take us through an evolution here of how we get from code and fix eventually to some of these other Agile things. Yeah. Yeah.
I think for the point that says can't measure progress,
Yeah.
I think when you're a beginner or an amateur, you don't even know how to measure your progress. You can't even estimate correctly. So if you say, I want to do 4 tasks, 3 might be easy, but the 4th you don't even know, and it could take like 50 hours.
Yeah.
And then you're like, it's easy, 4 tasks, and then you kill yourself.
Yeah. I'll go as far as saying too, and always I try to restate the question for everybody, but so beginners and intermediate, it's hard to measure progress, even for experts, I would say.
Okay.
We say maybe 2 weeks, and who knows, So, and I think, especially in this strategy, it's especially impossible. I completely agree. All right, so this term I just wanted to call out specifically: separation of concerns. Sometimes you'll see SOC, but the idea that again you can build software without relying on knowing all the nitty-gritty details of something. Yeah, that's all I need to say about it. All right. My other anecdotes here about, I did have a colleague who was very much into this code and fix strategy. He was a very good programmer. And he would write several thousand lines all in one C++ file. I might have told folks about this. It was kind of wild. And he'd break all the rules. Just write a function that's over 100 lines. He wouldn't break things into classes or functions. He wouldn't think about that. He just wanted to discover if it was possible. So again, the sort of discovery phase. So as long as you're going to refactor, or maybe this is part of your plan, and we'll get to sort of that as part of the Agile, some of these things about just making something that works. Maybe that is your first sort of subtask, and then you can break it down. But the idea with code and fix is that you don't have any. You're just going to code, fix when you run into a problem, and then just keep adding code forever.
I think that's when testers come into the play. They're like, oh, we cannot test this one.
And this is where testers come in. Yeah, and depending on who you talk to too, companies are sort of shifting and saying, well, why aren't the testers and coders, or why aren't the actual developers doing tests too? And so we'll get to that when we talk about testing a little bit. Let's see. So yeah, and again, the last note on this, because I think we kind of get the idea, is this probably isn't a good style for teams. It would be a fun experiment if I put us all together on the same team and just said build mini paint, and that was it. That was the specification, and see what we end up with. Maybe there would be some self-organization, but if I stopped that and said no, you can't talk to each other, that would be a fun class, I think. Another case study on this, again, since I've done a lot of games work, kind of an older game. There's this game called, ironically, Duke Nukem Forever here.
Oh, I love this game.
And it did eventually get done, but a typical video game takes about 1 to 2 years, maybe 3 if it's a real big budget, with Hollywood, special effects and all sort of stuff. But this game took 14 years to make, so
Not worth it.
yeah, and it wasn't even a good game, right? So when you think about some of these things, you should plan. 14 years is a career, right? Most people, who started on that project might be thinking about retiring. Right? So holds a Guinness World Record for longest development period for a video game. So you can research that a little bit. Kind of a software disaster. And a lot of this was budget problems, poor scheduling, and a lot of code and fix, I would say. All right. All right. So now we have some sort of process to think about or go from code and fix. What are the actual software processes that we want to use, or how can we take this sort of abstract idea and break it into pieces? So we call this the software development life cycle. It's going to be abbreviated SDLC. I'll try to write it out every time though. But again, with our goal is build good software that's within budget, as low cost as possible, and deliver this to your client as fast as possible. Okay. And the idea too is we're going to look at a few different processes, and again, as I'll try to say in every computer science class I teach, it's all about trade-offs. So I'm not going to show you a best software development lifecycle. You're going to have to come to that conclusion based off of what software you're trying to build. So is it a 100-line prototype in Python? Sure, code and fix, get it done. Is it a video game? Maybe choose one of the other processes. Is it Facebook? Do whatever they weren't doing yesterday. So, all right. So we'll have a few to look at. Code and fix. We're going to talk about some waterfall style and then some agile style. Right. So agile's typically the big buzzword, but we'll try to give it some identity or so you could explain it. A common interview question I get is, have you ever done agile development? And then they say, what is it? I mean, you kind of explain to them what it is. But it's, they got to ask. And I'll try to give you some answer to that. Okay, and so those are the styles that we're going to look at that I showed you, a few of them. But if you search, sort of Wikipedia for, software development lifecycle, you're going to get this huge long list. So there are many. They're still trying to make new ones and improve processes, right? Something, if you're more interested in the product management or product manager side of technology, I mean, maybe you'll be able to innovate somewhere here. Or, eventually your path might be stay technical for 10, 15 years or whatever, and then manage software, and you'll think a little bit more about this. Okay. All right, so here's the software development lifecycle in a few pictures. You'll see a few different ones. I'll choose a few. And depending on the picture that you look at or what company you're working for, they might look a little bit different. Usually 5 or 6 steps. Maybe 4 to 6 steps is normal. But this is what we have here. Okay, so slight variations, that's okay. So I want to show this one from Synopsys, because they have a nice illustration here, and it's very clean. Has anyone here worked or co-op at Synopsys? Well, last time I showed this, somebody rose their hand and said, yeah, that's what we use. I work there. So you never know. You can tell me if I'm explaining it wrong. So here's the real companies, and you can Google some of these and find them. It might be interesting to see like Google's or Facebook's. So. All right, I'll stop picking on Facebook. But here's the idea here. So you've got a few stages here: planning, designing, implementing, release, respond. This one has 5 different stages to it. All right. So during the planning stage, usually the first question you want to ask yourself is, what's the feasibility? Is this project actually possible? Okay, so sometimes big companies, as I mentioned, will come to consultants and say, can you just build it? Is it possible? Or is this technology 20 years out? Give us, what can you build? Does anyone remember Google Glass a few years ago? Yeah, maybe you saw that. So was feasible, deployed it, could build it, but I wonder if part of their feasibility study was, would people actually use it? Would privacy be a concern? Some of these things. So, you have to kind of think about what these questions are. It maybe 10 years from now, the answer is yes. People are just more comfortable sharing more stuff or being on camera all the time. So Google Glass, if you weren't familiar, was a pair of glasses with a camera in it and I think some sort of display as well. Basically your smartwatch or iPhone over your eyes. Okay. So once you figure out though if something is feasible or possible, then you sort of perform a requirements analysis. It says, okay, we think this is possible if we get X, Y, and Z. If I have X dollars, this many engineers, access to this API, right? Can I compile SFML? Is it open source? maybe you need some like physical structure if it's more of a hardware project or whatever. You're sort of doing this we call requirements gathering. Okay. Then after this, we start doing some design. So this is, the user interface, user interaction stuff. Usually this comes in the type of like a paper prototype or even just, whiteboarding something. Just sort of sketching things out. What's the software supposed to look like? If I click on this button, what's the next screen that's supposed to pop up? Okay, what are all the options that should be listed? There's some famous stories about these types of things. If you take the HCI class here, does anybody know how they prototyped the Palm Pilot? Palm Pilot being like the first smartphone, so before iPhone. Anyone know? How they prototyped it was the person who was proposing that, hey, it'd be a really good idea if we had phones with keyboards on and could, type things out and have applications. Well, they basically just gave him a chunk of wood that was about the size of the Palm Pilot and said, hey, carry this around, the city all day, put it in your pocket and see how it feels. And every once in a while, pull it out and, just pretend like you're doing stuff. So these prototypes can be pretty, they don't have to be functional necessarily, but again, it said, is it feasible to have this, block of, this big device in your pockets and carrying it around? Is it too heavy? Is it, would it look weird to strangers? All that sort of stuff. So that's part of the user interface stuff. And then, figuring out some of the software structure here. So this is going back to, some questions here. What are the classes going to look like? Are these going to be functions? What are the critical data structures? All these sort of things, sort of doing the class diagrams, the UML diagrams. Again, just designing or sketching things out here. All right, and then only after you've done those things do you start the next stage, which is implementation. So again, you've got your game plan. You know what it's supposed to sort of look like. You know who's doing what. And then you have your sort of list of requirements that you can sort of break your project down. Okay. In the end, goal at this stage of your implementation is to have some sort of working program or prototype at this point. Okay, and then once you have something that's working, then you can release that software out into the world. Okay, you can put it on your website, have it downloaded, the App Store, whatever. Okay, the public eventually gets your software here. Now, of course, as we know, not all software is perfect. So we do have to respond. That's a perfect opportunity to say, not all software is perfect, Facebook. No. I really can't wait to figure out what happened. So, things will go wrong. Users, or maybe they don't go wrong, but users request more features or say, hey, wouldn't it really be nice if we had this thing? So you have to respond to this. Whether it's a customer support, bug request, whatever it is. Okay? All right. So, and then what? It ends, you're done? Well, no, then we repeat, right? The cycle. Software goes on, there's always more to add, more features and so on. All right, so a question though to you folks out here. Which of these stages, because we went through 5 of them, and let's say, you had to allocate most of your time and energy to one of these stages. Because folks who don't allocate a lot of energy to one of these stages tend to have a lot of bugs later on in their software, or it costs a lot financially. Now, which of these stages do you think tends to be the most important? Maybe I can phrase it that way. Everybody hold their guess. Maybe I should do it by show of hands, just so everybody can. How many people think it's the planning stage? How about design? Okay. Implementation? Release? Response. Okay, interesting. Well, I won't say which is right or wrong. I'm going to pick on one from some empirical evidence. that tends to have the most bugs and so on. Yeah.
Question. So how do you differentiate between the plan set and the design set? How do you like not merge them?
Yeah. Yeah, I guess sometimes this could be who's involved maybe at this point. So maybe the planning maybe at this point could just be like, say, a business owner, somebody non-technical who says, okay, is it possible to make glasses that we can, see a, user interface and have a camera and those kind of things. So that might be one way. It's very likely, I would think at most places, at each of these stages, there are some business folks, some financial folks, some engineers, some HR folks, everybody, sort of pitching in, at a senior level, maybe at some of these stages. I mean, some of these are going to be a little bit more tightly coupled. When you're doing the design, is that planning? Sure, maybe some parts of it. Yeah.
I think it's more like budgeting and all that stuff, right, in the planning phase.
Yeah, this could be a lot of budgeting too. Yeah, just to see again the feasibility, however you want to break that out. Is it coming?
When you asked about the most costly error, I also thought of like missed opportunity cost.
Oh.
Like that might be a planning problem. Like, let's say Yahoo during the 2000s,
Mm-hmm.
they had a missed opportunity cost, and that cost them the entire internet sector.
Yeah.
So there's that, but then there's also the actual implement, kind of like the how do you call it? Implementation.
Implementation.
error.
Yeah. Okay. Yeah. So maybe I should quantify. Yeah, because depending on how we're thinking about these steps here, right? Like an acquisition, right? 2000s, a lot of. Let's see. I forget the exact logistics on the Yahoo deal. Who they missed out on? They were gonna buy Google, was it, for some amount of billions of dollars?
Maybe Yahoo acquiring YouTube, something.
I think it was Yahoo acquiring Google.
Oh, that one.
Yahoo acquiring.
Something like that.
Oh yeah.
I'll have to check. I think that's now. There was also another missed opportunity. I forget. I think Microsoft was going to buy YouTube as well at some point. So yeah, think about this in terms of opportunity costs. Okay. So thoughts.
I was just gonna say for the feasibility for time, because I don't know how you would describe this one for most costly because I'll give you an example at work that I work at. I implemented a new program that uses accountant securities for equities.
Mm-hmm.
So there are 3 different types of equities. A security ID that goes by the one of the business, and then there's one that's a security ID that goes by foreign entities, so like other countries.
Mm-hmm.
So, and then after the release and deployment of this, it was later on discovered, our thing is a requirement for our security in our program, but on the foreign entity, it's actually not a requirement in their programs. So there's going to be always a mismatch of their stuff.
Yeah. So this is sort of the comments about. I guess it's about the planning stage and just trying to figure out who all the stakeholders are, who all is interested in the outcome or involved with this. It gets really tricky when you have international requirements as well, I should say, and where costs come. And so I would put that in sort of like planning and designing idea. Let me put us here though to the original question, and I think I can move this forward without thinking, both with thinking about opportunity costs and as programmers with our daily wisdom here. So there is a law about this, that errors are most frequent during the first 2 stages, requirements and design, and they're the most expensive the later that they're removed. So you could think about this in different ways depending on where you raised your hand, right? If you said the response, maybe that was the most important to you, but depending on what software design lifecycle you do, that's probably going to affect your planning for the next iteration, if you're doing many iterations. But the sentiment here is when you don't plan for something or design for it, if you've got to fix it later on or implement a new feature or respond to something that was improperly designed, that's going to cost you more money, essentially. Okay, and I'll quantify that with a little chart later on to, they studied this just to see how much money. And when we talk about some of the software design life cycles, some just follow this process once, so this makes perfect sense. If you forget something, it's going to really harm you later on. And then some are more iterative, and we're going to find out the reason they're more iterative is because it makes omissions in the planning and design stages a little less costly, right? Because you're just thinking in smaller chunks. Okay, so this is Bohm's first law. I'll have to look up what a second law is. This is the only one I know of him. But yeah, and it sort of makes sense intuitively, right? When you get caught by surprise, if you have to implement some fix later, it will cost you. All right. So with that in mind, and we'll put some numbers to that from a empirical study. I want to talk about agile versus waterfall life cycles. Okay, so two terms you've likely heard, and if you put in waterfall as the first word in Google or agile, you usually come up with which is better. So you'll have to think about it. But there's sort of two main schools of thought about this, in which other life cycles fall under. But waterfall, the idea is you plan almost everything up front and then you start development. Okay, so you sit down with your friends and you just say, what's every possible requirement? What are all the features we need? And then only once you're done with that do you move on to the next step. And you say, okay, let's design it. We need all the stuff that we need. And in many cases, you very strictly follow that. Okay, so once you're done planning, once you've designed the user interface, you don't go back and change the user interface because you're implementing. Okay, but that's as opposed to agile, which says you iterate very incrementally. So that means you just do a little bit of planning, then a little bit of design, a little bit of implementation, a little bit of all the steps, and then you revisit that cycle again. And you start doing just a little bit of planning, a little bit of design, implement, test, release, and so on. Okay. So my question is, pretend you're in an interview. Which style is better? It depends. Okay, yeah, let me, perfect. All right, let me give you a scenario. Let me give you some context. For one, I'm trying to think. You are trying to think of a real company to pick on. You are see if you can guess the company too. Not quite. You are a brokerage firm. You offer, you're a stock trading platform, and you offer commission-free trades. It's really important that these trades are honored in a timely manner. Clients don't lose their money. Any brokerage. How about Robinhood? Yeah, maybe a popular one. What do you think? Should they do waterfall or agile? And I'll let you defend whatever your answer is. I just want to know what your trade-offs are. Yeah.
I'd say waterfall because it would honestly probably be illegal to ship like a half-built trading route because then like half the trades would fail or there just wouldn't be trading functionality and then you get sued and yada yada. So you would want to like release a fully working something and then maybe like add features later.
Right. Yeah. So it's pretty critical that features implemented right. You meet all the regulations, right? So for folks who are following along the stock world and what happened with GameStop and AMC and some of these things, right? There were fiduciary duties that had to be met and all these sort of things that you have to plan around. And so yeah, banks are typically an example where you need to plan a lot up front. You need to really make sure too when you're writing your code that people's money is just not going to disappear because of some bug, right? That's pretty critical. So you should have your data structures planned out. Take you back to systems. Locks and their threads need to be in the right place. So pretty critical. Yeah.
I'd actually go with Agile for this one.
Agile
Yeah.
for Robinhood.
Yeah.
Yeah. Defend it. I'll let you defend it. Yeah.
Alright, I mean, like, you don't have to actually make trading available till maybe a certain release. So you can keep on incrementally developing upon something, and then maybe test it a bit, and then you can just say, oh, it's now released, because once that happens, you can then have more trading flows coming in, instead of you trying to release everything all at once, and then have a disaster on your hands.
Okay. So you're saying you could have some sort of right where they're releasing different features, whether it's buying stocks or equities or whatever. Maybe just work on that feature, and then maybe you can add other features where you more advanced stuff.
Also, like,
Sort of.
especially when you come to different currencies, you have to have each one, so it's also kind of hell.
Yeah. So yeah. Okay. So there's actually with that line, and I'm going to talk about a specific type of waterfall. That actually sounds sort of like a spiral, which is part of waterfall, where you plan a little bit, and then as your company grows, you'll slowly have these larger and larger planning phases as you add features. That actually, it's iterative, but it's actually still a waterfall style. Yeah.
The other example that I could think of is like when we are dealing with medical grade equipment and generating software there.
Yeah.
That's when actually we do not want the agile, but maybe waterfall and then.
Yeah, so medical data, stuff that's super secure. Trying to think big medical, any hospital, Boston Medical Center, Epic, big electronic medical records, these kind of companies.
I mean, if you're like managing software for like an IC or something, right? So you do not want something to just go have a bug and like. I mean, what happened with Facebook? You cannot like have that thing in the hospital.
Right. Right, yeah, you can't have the hospitals go down, right? They need redundancy and all these things. I'm trying to think of what's another really hot startup company right now that's kind of big.
Well, so how much of that can you kind of push over to, maybe not coding style, but you hear in like automotive or like different types of industries that have like very rigid, like we're gonna code this in C, but like it has to be this like specific style of C programming because it's safe or.
Yeah.
So how much of that can you just like push off to, like, oh, okay, we're gonna follow these strict coding style rules, and how much of it is like development process?
Yeah, that's a great question. It gives me the idea for the company. Let's think about Toyota, for instance, the automotive company. They would be one. Well, first, I guess I'll give you first dibs if you want. If I'm Toyota and I'm doing manufacturing, and I tell you, so just to give context, safety is really important. We have these particular guidelines that we have to make sure we meet. We're not allowed to use these features of C++ because it's not safe, or there's sort of weird behavior. Would you say it's more likely we would do sort of more planning up front and then implementation, or would it be more iterative?
I would still think it's more likely to do waterfall.
Yeah.
Just because you'd rather be extra sure. Like if you're making the decision to be like have security in the language or restrict the language to be more secure, you think, but maybe that's a fallacy. Like maybe development style isn't necessarily one for security.
Yeah. It is kind of a tricky one. I think it's a good thought. So historically, especially if you're a car manufacturer, a defense contractor, if you build airplanes or something, you're probably following a waterfall style where there's a lot more, at least at the front of the planning stage and design stage. And I think a lot of that falls into like regulation and just how to properly design something. Now I think the example I use, Toyota, is kind of bad because they're also famous for being very fast and iterative.
I feel like the banks.
Banks is an easy one where you
Banks
definitely
is like almost always
have
waterfall
to.
for older systems.
Yeah, I guess maybe one way to think about it is if you're building your software, how much upfront would
Knowledge
you
need to know.
want to know, like you have a bunch of these data structures. So this isn't to say that you couldn't run waterfall twice or have a second round of it, but you would really want to have key data structures in the core not change that much. I guess maybe that's one way to think about which style to pick. The other company I was going to pick was Tesla, but they're sort of weird because if you ask them, they say they're a battery company or they're a car company or they're a software company, depending on which step. So maybe we should look at some of these more closely and just think about it. But yeah.
Would it be safe to say like more hardware-based products tend to skew towards waterfall because like if you're designing like a navigation system for like a Boeing airliner, you can't once the plane's been built, you can't really there's not a lot of stuff you can change in terms of other technology around it.
Yeah, that's a nice way to think about it, right? Thinking about the opportunity cost. If you're, if you have to wait 3 months and get the, shell or whole of the airplane or whatever, and you only get a few chances to iterate on it, right? You really want to, have your plan in place. I think that's the other way to think about it. How costly is it to iterate? If you're just building a video game or something, right, you can just hit recompile and add features or whatever. But if it's an airplane, right, you don't want to test that thing 30 times in a week, right, to see if it can fly or not.
Do you think there is like any company which like specifically sticks to one design pattern or like design choice? Because it could be waterfall when it comes to like releasing for the customer, but with internal teams and then you actually have to distribute within that could be agile as well.
Yeah, almost every. Has anybody worked for the government, whether U.S. or anywhere else? Yeah. For the folks who rose their hand, did you have to bill by the hour or had a timesheet?
Yeah.
That's very specific. You did.
I have
Other
two
folks?
separate time sheets, one for the project and then one to get paid.
Two different ones, but pretty specific billing, right?
Mhm.
So usually, government or anywhere we're using tax dollars, lawyer. I don't think we have any lawyers in here. Former lawyers. You bill every 6 minutes, I think. So there's various jokes about that. Usually those ones you tend to, because you're billing for every hour, stick to the requirements and not deviate, unless it's been planned on and these kind of things. So government, military, and again, maybe the example with like airplanes, like a Boeing and stuff, pretty strict. Even in a sense, a researcher, in a way, if I write a grant for money, and I get it for research, I can't just say, I got a pile of money and do something else. I have to execute my plan. Maybe I do it agile style, but I planned everything up front. I said what I was gonna, here's a prototype and so on. So I'm waterfall, I guess. Okay, so we get the point here. But it is interesting to just think about a company and what would sort of be optimal. Think about it from, your use case. If you're building a startup, how would you do it? Okay. Before we jump into these, I think I've got a break built in somewhere, but we've been on about an hour and 15, so let's take a break for 10 minutes, so 7:25, and then we'll jump into waterfall. Yeah,
I
hi
have
there.
a quick question about that.
Sure.
Yeah, so I'm doing the last part, singleton.
Yeah.
So, if there's like a old style, new style of this.
Yeah.
Yeah, but at first I use this.
Yeah.
And there's no arrow, but the thing is that I cannot satisfy the needs because it says the first time you create.
Yeah, okay.
Yeah.
So this example is a little bit weird
Yeah.
because, I'll try to show this here in instance. Okay, so we have this static, configuration manager
Mm-hmm.
here, whatever.
Yeah.
So the weird thing about this variable here is called instance. Now functions actually have some address in the program. They're stored somewhere.
Mm-hmm.
So when we're doing this first check, if instance is not equal to null pointer or something. The weird thing that's going to happen is it's actually just looking at this function.
Professor, but this is like something else.
Oh, it is something else. Oh,
Yes.
okay, it's gonna.
Because this time I'm using the old one.
Okay.
The old one, but if I use old one, I can satisfy the requirement. But the thing is that it always gives me this error.
Linker error.
Yeah, and also I tried this.
Oh, I see. Yep.
Yeah, my first computers say same thing. So.
Yep. This is actually a different problem here.
Yeah,
So this one, let's see. So you have some. Oh yeah. Okay. So you've got this static variable. So this here at line 55, static variables have to be initialized somewhere else. So that means outside of your class, you have to come out and do configuration, manager. So that's the class. And then where it belongs, either lowercase instance, and that's
Yeah, that's that.
logger. What's it called? Oh, logger is what this is.
Logger.
Yeah. So outside of your class, you actually have to initialize this and set it equal to, if it's a pointer, just set it to null pointer.
Oh.
So, yeah, if we don't initial static member variables, then you'll get a linker error. It'll say, well, hey, you said you had this static thing. You have to tell us what the initial value is.
Oh. Okay.
That's, yeah.
I mean, the new cell, because it didn't use that, so there's no problem for that.
Right, yeah, because it just had within the instancing a static variable.
Yeah. But the new cell is good, but cannot satisfy our needs, right?
Yeah.
Okay, got it.
Yeah,
Thank you.
sure.
I hate waterfalls.
Yeah, you're waterfall, right? Because you're at a
We are
bank.
hardcore waterfalls.
Yeah.
It's we're actually trying to transition to Agile right now at this moment, actually.
Interesting. Yeah, I mean, I guess once you have the core system built, I mean, maybe that's the thing. That's like these can be fluid, right? These styles, depending on what project or what where you are in the product's life cycle, I guess. Yeah.
Where everything goes to hell, it seems that because of the, especially I work on accounting systems and like core financial building systems, things aren't very clear where things kind of go.
Yeah.
They just still build it on. So they don't know all the requirements beforehand because it's going to be complex.
Yeah.
So, and so even a waterfall guide with a very, very complex, and even an application that I work on, even though I'm part of one team, we inherited an application,
Oh, okay.
and there's no people that never worked on it that are still in the company. It's not documented at all. It's a disaster.
Yeah. That reminds me of something I should bring up at the end of this, or I guess somewhere in this class I want to talk about it, because often we don't think about how it's going to be maintained and how long the code is going to
Basically, they say until where everyone dies. That's like our typical.
Yeah. I mean, maybe it's obvious in some of these
The
cases.
thing is, like, we still have code, but it is
Yeah.
So, like, they just say, point.
Now, is that actually part of when you write your requirements? You do that to your company, or?
So they don't typically do the maintenance thing, because the thing is, our principal engineering standards is off that standard. So like that really doesn't matter at all. And no, all they really care about is the expected
Sure.
Like right now, mine is like the registration location code, but after that, on the security ID and the identity. But like one application is Illinois, it's like the Illinois one. They have what's called ISIN. It's mandatory over there. But there's also CISP and CEDAL as a security. Those two are optional. On our system, the Q-SIP is a mandatory. ISIN and CEDAL are optional.
Interesting.
So it's like, yeah, it's kind of a disaster when they kind of wrap the data up like.
Maybe that's the planning stage.
That's why I like when you think about it, like you just find out and like release it at this point. I'm sure that's kind of look at it. Because you anchor it, you know that it's waiting that deadline.
Right.
Because they're the ones who order the requirements.
Yeah, I mean, half the time that's the problem, right? Getting it right to talk to each other.
And even like they don't know what kind of occurs. So, I really read like a new unit someone telling me, no, you don't do that, it's like this. And I'm like, no, it does not. Let's prove that real quick.
Yeah.
So it's kind of been a disaster. They've actually, my boss literally gave the project manager today, because we submitted this week, like we're wonderful. So once you have your RFRS, that doesn't change. That thing is down. So, this guy is
that's why you're saying that
4 or 5
Yikes.
So, he's like, everyone just gets it. It's normal. Like, we're all trying to deliver that job. That's what the main requirement is. DevOps,
Right.
those are the buzzwords.
Yeah, interesting. Let me see if I can sneak something in here, actually. About code lifetime.
Are we going to talk about DevOps on the
Deadlock?
Yeah.
Not really. Let's see. Let me think of it. Yeah, I mean, it really does. The project that we're going to do is there's potential for deadlock, so I guess we will have to talk about it, and if it matters. Let me get to the project. Yeah, it's probably not going to matter that much. Just because I can't have required everyone to take in systems.
Right.
Although we're gonna do some systemsy stuff, so yeah. We can't escape it. I just put it in. So we will do some. Yeah, so the project's going to be shared in one repository, so there won't be any escaping that kind of stuff. How to sort of navigate a GitHub project and some of these things. We'll have some like automation stuff. It'll be pretty cool. Yeah. So every time you like push to the repo, it'll check the code and figure it out. Yeah. So not that, but like every time you push to Git, run your unit tests, run different code checkers, make sure somebody approves your pull request, basically. Pretty standard. I mean, at least approving pull requests is pretty standard, and running the tests and automating. Most places will do that. Again, they should all be doing it, in my opinion. Yeah, so there's plenty of stuff. Let's see here. We got maybe 1 or 2 people here.
Which one, at PlayStation and Intel, what did they do?
At PlayStation, we were. I guess it kind of changed. We were waterfall for a little bit, and then agile all the way. Intel, most teams I was agile, Scrum, daily stand-up meeting, and you plan sort of 1 or 2 weeks. Yeah. We didn't use Jira. We used some other weird system, but yeah. Alrighty, folks. Let me get us back in action here, and let's talk about some of the waterfall development and agile. Something that came up just when we were chatting up here and thinking about some of these different styles that I always forget to put on a dedicated slide, but when I was talking with some of the Google engineers, Titus Winters, and then another guy I know, something they got to be pretty senior level, to the point where they weren't really writing code on a daily basis, but they had to think about some things. And one of the things they think about when doing this planning is just how long does your code live? And then they start actually putting those kind of things in your requirements. So it is something to think about. Right, so again, going back to our code and fix, is the code just going to live for a week, or is it going to live forever? And we're thinking about different banking examples, or airplanes, or whatever software we're developing for these different industries. How long does that code have to be maintained? And maybe that has to do a little bit with how much do we plan. Okay, so that's a good thing to be thinking about, maybe with the waterfall style. So again, a little bit about waterfall. This was the model developed, in the 70s or so. So you can read about who invented it and stuff. You'll notice Bohm here again. And of course, it's from Bohm's first law. But the key idea with waterfall is that you just absolutely do not move to the next stage. Generally everyone's moving in unison. So once everybody's planned everything, then you go into your design stage. And once everybody's satisfied there, then you move on to your next stage, implementation or whatever. Okay, so here's a waterfall style design. You'll notice that this one has 1, 2, 3, 4, 5, 6, 7 steps. So again, they can vary a little bit, 5 to 7 steps usually. But that's the idea here. Here's one with 5, different steps. But again, the basic idea for the waterfall step is, you have to start the project out, start communicating, gathering different requirements, and sometimes you think about these as different scenarios that could occur. All right, sometimes we call these user stories, and you sort of write these in the terms of what some user is doing or what they're trying to achieve. Okay, and through that you're communicating, well, if the user is trying to do this thing, then this is one of our requirements. We need this feature. Okay, so that's the first sort of step here. This is going to be what your lab's about today, looking at some of the mini paint things that we did, and then actually mapping out who the stakeholders are. What's the primary system involved? Okay, so they'll have a template like this. You can look back at this one if you want. That'll have these different ideas here. Okay, and usually, there's some sort of use case. We're going to just write them out as use cases. And, you'll write down certain things like, what's the priority? Who are the actors involved? Is it the customer? Is it the system? Is it multiple customers? These kind of things to think about. Okay, and people actually write these out, and then they are helpful, right? It's on paper. Everybody can see what the use case is, and it's all in one place, right? The point, again, isn't that it's living in one person's head, and their ID might be different than somebody else's. Okay, and they even usually go as far as sometimes you have pre and post conditions. So depending on who you took object-oriented design with, maybe you wrote some of these pre-conditions, post-conditions, or thought about this in sort of a testing idea, but those would be some of the important parts. All right, and then of course, after you've written everything down, in this waterfall stage, you start doing some planning. So as to say, all right, we got a bunch of these features, all these requirements. Well, how long do they take? And then maybe you've seen one of these charts. It's pronounced a Gantt chart. Basically, on the left, it has your tasks, your features, or each of your requirements, and then you've got a schedule here. The longer the bar, the longer the task that you're estimating it will take. And usually these could be weeks at a time or days or whatever. Okay, so that's what's going across on the x-axis. And usually a project manager will say, okay, we estimated, whatever this blue bar is here, and then maybe they'll fill it in with the, this black bar. I'm making this up, but just how long it actually took. So the estimated time versus the actual time. And then that's how people maybe get an idea of how long tests take, right? So we had this discussion on, even experts don't get it right all the time. Maybe they have an idea, but it is hard to estimate. But this is one way to keep track of, are you on schedule, and if you're missing schedule all the time, maybe you need more engineers or more of something. It's a way to track progress. Okay. All right, so then the next stage in this waterfall design is modeling. So again, you might see the stages like this. So this could be part of the design work that you're actually doing, right? You've planned and allocated, right, in your chart before here, a month for design. Okay, so you're doing some of that in the modeling stage. And then sometimes it's also building models of your system, right? The actual class diagrams, what you think the code will look like. You're not writing code yet, but again, you're just building it out. So yeah, here's some modeling, right? Some technical elements are starting to get built. All right, and then finally we can get to the fun part, writing some code, the construction phase. And with this, usually, right, we want to be writing tests alongside of our code, so usually those are going hand in hand here. All right, so there we go. And then we get to release our product into the world and get some, feedback. All right, we call this the response, or I guess the release stage and response in the other synopsis diagram. But then we hopefully, get our customers and deliver them a good product. Okay. Again, usually you want to gather some feedback on most things that you deploy. So it could be on a questionnaire or whatever. All right. Let me. I think we've actually hit a bunch of these. So I want to ask about the other ones. So again, pros, cons. Just to summarize, waterfall. The nice thing is, usually for waterfall, since you've planned everything out and you're moving one stage at a time, you never release something until it works, right? We don't get to, right? We do all the code and testing right here, and even if it takes us a really long time to get to the deployment stage, we don't get there until the code's done, so we know that it's done. All right. All right. So that's the sort of planning stage. Cons of waterfall, again, hard to sort of pivot. Okay. Again, you can't, even if you're doing the coding stuff here, you can't really go back if you say, well, actually we wanted this other feature. There's no rolling back, ideally. And then, of course, if the customers want something ahead of time, they have to sort of be patient. During the planning stage, they can't have a prototype. It doesn't exist. Okay? And usually they understand that, but, that's the idea. All right, so next slide, I promised some numbers to waterfall, for how costly are oversights here. Okay, so this was one of a few studies that I was able to find, but they said it costs roughly 6 times more to fix a bug found during the implementation stage versus design. So that means, again, put a figure to it, $100. Think about it in terms of engineering time, maybe. If you planned to write some, correct algorithm or something, but you don't find the bug later, it took somebody, a bunch of hours to fix it, and that costs money. Okay. This is probably a more intuitive visualization. So, the bugs and stuff that you find at the design stage, you can think about this as in hours, if you want, engineering hours. one-to-one, right? Things that you designed for and planned for, not too bad. But then if you catch the bug in the next stage when you're implementing it, you say, I didn't really design for that, but whew, lucky I found it. I was wondering why it didn't work. But you eventually figure it out. But if you don't find it, during the testing, and I'll put this as sort of testing and debugging, sort of figuring out, what went wrong here? Well, we got to talk to a bunch of people, write a bunch of unit tests and stuff. That's, some cost here. And then if we get to the maintenance stage, it can be roughly 100 times more costly than if we had just planned for something at the start.
So with waterfall, since you're going through kind of the ceremony of all the steps.
Yep.
Maybe ceremony.
Yeah, sure.
Does that mean that you'll have a tendency to take on larger feature sets, like for what you're doing, since you have to like go through the entire process? You're thinking instead of a tiny little feature, we're going to group of 10 features, or like a big release, or something like that, as opposed to like, hey, let's just implement this tiny little feature and try to go through it a bunch of times.
Yep.
I
Yeah, that tends to be the case, and it sounds weird, right? It's kind of counterintuitive, but again, if we just think about it from sort of a financial standpoint, or I think about this if I'm writing like a grant or something, where I think really, really hard about, okay, what do I want to do? And then I write, a big contract that says, okay, I think this is going to take me 20 hours to do feature X. And I sort of spend that whole time documenting everything. And then when I give it to, whoever to give me money, they can go sort of bullet by bullet in the planning stage and say, okay, we buy that. So at that point, I'm kind of locking myself in. I'm saying, hey, this feature that I want, it's going to take 20 hours or whatever, and I really try to just spend those 20 hours exactly on that feature and not backtrack. You tend to, again, if we think about this in terms of like a contract or something, like a government contract, you plan it all up front and then you move along. Now, I'm sure there is some agility within, how things get organized, right, pragmatically, but it is more rigid. And it's meant to be.
So in waterfall, we are not actually moving to the next phase until we are done with the previous one.
Yep.
So that makes me wonder, like, how much testing is actually good testing. Usually.
How much testing is actually good testing? Yeah, I mean, right, because you're maybe saying, hey, it might have been useful if we had the customer feedback, and then we could, if we have thousands of customers, maybe they can report a bunch of things, and then we should go back and test it. Yeah, I think that could be useful, right? Or maybe to start testing earlier, right? Again, depending on what, your first computer science class, whether it was in the Align program or undergrad or whatever, usually we get people writing tests earlier, as they're writing the software, in this implementation stage and stuff. Yeah.
That's another one that's usually kind of like thrown out there is I guess after I know like we've had this problem because we work with a lot of data is volume testing, because it's only like one region with production that has the amount of volume that would actually be able to test your code to the actual strength.
Oh yeah. So talk about the volume at the end of how many customers we have.
Like usually testing qualities would never have the same kind of volume like production.
Right. Yeah. So the comments about, right, when we're just testing in-house, right, if this is Mike's, software company, I'm one person, every test that I can dream of, and, I've got 3 laptops that I can test on, and, this is a great example of what goes on when I deliver homeworks, right? I try to do it on, at least 2 machines, and then I send it out to you folks, and you say, well, I can't get it working on this IDE or whatever. And that's somewhat expected, right? But it is sort of a volume, right? The actual test, or we can do the data gathering, comes from getting some volume, right? Different machine specs, different operating systems, all different architectures, all those variables. That's a nice example. I do this sort of waterfall on my end, send it out, and then get a response, and then we go into agile mode as fast as possible. Okay, so the question is, then, how can we improve on this? And maybe this is, again, intuitive, but of course, we can have waterfall multiple times. Okay. So you say, okay, maybe we can build this into the plan. So again, put yourself in the mind of somebody trying to score, a really big multi-million-dollar government contract where they give you a bunch of money, but you try to break it out into 3 phases of waterfall. We're going to do all the planning for at least the first iteration, and then you plan out what the phase 2 is, where you're like, all right, this phase 1, this is our core system. We still know what features and stuff we want in phase 2, but we want to make sure we go through here, and maybe we'll buy ourselves a little bit of time here. And we're going to buy ourselves 100 hours for, fixing or responding to customer things and writing tests. And you can kind of build that into the next iteration in your planning, right? Planning for the unknown in a way. You're still rigid, right? You're still committing how many hours that you have to some task, but again, you're just breaking it into iterations. Okay? Yeah.
Can you elaborate more on the difference between an incremented waterfall versus agile?
I will, yeah.
Okay.
So agile versus, this is starting when we talk about agile to look like, that's what agile is, right? A bunch of iterations that are really quick. So yeah, this sort of makes sense here, right? Still waterfall, but again, there are, version 1, version 2, version 3 here. Okay. Let me try to think of some examples. Iterations here, non-software. How many folks saw any of the Harry Potter movies, 1 through 8, I guess, right? So they didn't, they sort of knew what version 8 was, but, they start executing on version 1. Or if you play any sports games, right, they have the 2021 version or whatever in 2022. Or if you buy a car, right, they have iteration 1, Toyota Camry, 2020, 2021, 2022. So, those could be some other waterfall things. All right. So, with this, pros and cons. Software can be generated more quickly. Right. So if I look at this here, I've got, version 1.0 down here. I've deployed something. Okay. In fact, I deployed 3 times. Okay. So now I have something that I can actually give to folks. Again, it's more flexible because I had 3 chances to plan, in a sense. And in those planning stages, I can, give myself some, wiggle room. Now the cons with this one, though, is there might actually be more planning up front because you're writing, 3 plans now. You have to sort of anticipate what you think you're going to do in version 2. Right? So thinking about this maybe from the movies perspective, like Harry Potter is maybe not a great example because, there were the books you could kind of follow. What would a good one be?
How about Game of Thrones?
Maybe Game of Thrones where the end's not finished.
It was good, but
Yeah. Folks familiar with Game of Thrones, I'm trying to use something that's pretty universal. Right, another sort of famous TV show, right? You don't know the end. And things get kind of controversial. I heard the last season was bad or something. I don't know. Right, so it was hard to make a good plan, right? But, you're still stuck with waterfall, right? You're still planning up everything. It's still pretty rigid. So you say, okay, let's improve here. So this is where we get to this idea of prototyping. And this is a little bit more evolutionary, okay? And it's supposed to be improving on waterfall a little bit. But the idea is, you sort of do your requirements, you do a quick design, and oftentimes, as I mentioned, that prototype's very simple. It could be just the block of wood that they're using for the Palm Pilot. You kind of build that. And then you go through this sort of stage of refining where you bring the user in really early. And you would say, hey, would you use, a phone that had a keyboard and a screen on it? Would you use, glasses that had a camera? And you just give these to a bunch of users and you say, go play, And then you tell us how you like it. And they give you some feedback and they rapidly do these iterations here, okay? Websites will do this all the time. this would be a good example of Facebook, but where if you ever look at somebody's Facebook and then maybe somebody else, they'll deliver some features that are different to some users than the others. Does anyone know what that kind of testing is called? A/B testing, yeah. User group A, user group B, they get different versions of the site, and then maybe they're collecting some data, or they ask them, how did you enjoy this experience? If more people from user A say, we loved it, than user group B, that gives them some feedback, right?
I think they also do it with different platforms, like they release some features in Android but not in iOS, and then maybe some design choices.
Yep, that's a great way to make it easy to figure out who your test group is. All right, so we'll push all of our latest updates to Android, and if the Android users don't like it, we'll hold off, for the iPhone or whatever. Yep, that's actually a really good strategy folks will use. All right, so here's just an example of a really, low fidelity paper prototype. Again, if you ever took the HCI class, I've taught it once here. It was a lot of fun, but I made everybody do a paper prototype. And you get a lot of resistance. And when I took HCI in grad school, I had resistance. I just want to code it. Come on, I don't want to build this thing. But it's amazing the actual feedback that you get from your users or suggestions, even from something simple like this, right? Some of you folks might be more interested in human-computer interaction, user interface stuff, and you'll go through this, right? Maybe it's on paper or a wireframe or a really simple design first, okay? All right, so pros and cons, some that I came up with. Keeping users active in the development process probably makes sense if that's your client, right? You want their feedback. Now, is the customer always right? Who knows? But you probably want their feedback, right? They're the ones ultimately consuming your product, right? Or I should say, is the customer always right about everything? Maybe not everything, but a lot of things they can have some insights, okay? Usually having this quicker feedback cycle too, again, is useful. And the model is straightforward. You see what people like, or whatever your metrics you're collecting on. If it works, that's great. Proceed forward. If it doesn't, retry. Okay. The cons: the prototyping takes time. You do have to find users, right? And it's probably, if you're, some web company, again, a Facebook, a Google, if you're delivering changes constantly to the same user group and saying, you're an experiment, keep giving us feedback, that's probably annoying to the users. So you do have to, have some thought about how you carry out your plan, okay? If you're going really wild directions, there is some waste here. Again, maybe if you're a car company, do the folks think prototyping a lot, is a good strategy? Maybe. I'm certain there are prototypes, but you probably can't have 50 iterations with 50 little features of a car and ask 50 user groups which they like better, right? And you have to identify your audience. That's actually one of the first things you do. You figure out who your stakeholders are, and that can be a range of of things when you think about the demographics. Are they, super users? Designing software for people who love the command line and using Vim and all these sorts of things is different than a full IDE, okay? So you get the idea, all right? Has anyone seen this? This is a prototype from Tesla, a Cybertruck. Pretty strong, right? They were saying it's really strong and the glass is bulletproof. Does anyone know what happens?
They break the glass there, and then they threw a ball out at the top of it. And
Yep.
it broke.
Here it is, everybody. On stage, they're trying to sell their product. They're saying, hey, it's bulletproof. And you can see his grin at the end. He's like, I threw it too hard, darn. But that doesn't look bulletproof to me. Anyway, so that can be one of the cons, right? You can have a lot of sort of positive hype or a lot of negative. If your prototype doesn't do a good job. There's some other famous examples. If at the end of class we get to it, I'm just going to write Bill Gates here for a second. Remind me, and I'll try to find the famous Bill Gates prototype when he's live in front of, I don't know how many thousands of people showing off Windows. If you want a funny thing. I thought this one was a great example of a prototype gone wrong. All right, so another model we have is the spiral model, and we're still in waterfall. Oh my goodness, how many are there? But again, we're getting more and more iterative. We're moving to the late 80s here at this point, but people are starting to wisen up. And they're saying, okay, well, during our first iteration, we're just going to do a little chunk of planning, and then a little bit of modeling, then a little bit of construction, a little bit of testing, and then we'll deploy here. And then the next cycle, once we've gathered some information, this is prototype, 1.0, then we'll do a lot more planning, and then each stage gets bigger and bigger and bigger as you go further out. Okay? So this is a way of sort of starting off quickly, maybe getting some user feedback, delivering something to your clients early so they have something to play around with. Then as you go, the iterations take a little bit longer and longer. Okay? I don't think this model is used as often, but you can think about some things like maybe operating systems on a very long scale are a way to think about this. Right? If you think way back at the early Windows, maybe it was a year in development, but now it's every few years for the next operating system. And maybe these spirals aren't always getting bigger, but something like that. Okay. Less releases as time goes on. All right. I think this is this picture shows it nicely, but if you want to see a video, we can you can check it out here. But again, just every stage is getting bigger and bigger as you go. All right. So again, this is iterative. As we go further and further, you figure out what features you want. Again, there's room for customer feedback, which is nice. The cons, we're still in waterfall. We're still following a procedure. We've still got sort of, some documentation of, all right, the first cycle through will take 3 months, and then we get 6 months, and we get 9 months, and then we deliver, or whatever. Typically this would be the wrong thing to do for a small project. Right? If we had for assignment 2, we probably wouldn't need to do a spiral model, right? Where we implement, okay, can we change the colors? And then we go through and we, send that to the customer and be like, do you like the program we have? You can change the colors. And they say, yeah, we like it. Then you go through again, you add one more feature, right? That's probably not the right, scope. So we have to be a little bit careful. And then this one can tend to be hard to predict the budget. And maybe this is a little bit dangerous because they're saying, hey, every cycle we're just going to get bigger and bigger and bigger. And your budget can sort of spiral out of control, right? Right? How many managers do you want to say or tell them, the finance division, hey, we've got this project, and as it goes on longer, it's going to get more expensive. Do you like that? Probably not, right?
Sounds like government projects.
Yeah, yeah. Maybe this is government. Yeah, I know. Come on, U.S., do better. Yeah. Right? Yeah, the debts or something. Yeah.
So it seems like we spiral. It made me think when we were talking about early overkill or homework.
Yeah.
It reminded me of the like we're talking about functions versus objects.
Yep.
Like if you have one thing or you're doing one small thing, maybe write a function that you would take.
Yep.
Seems like on a project scale, that could also happen where you need some larger object systems or larger refactoring when you're doing another iteration. But it seems like this is all designed assuming that you've completed your goal permanently in the smaller ring, and you get to the outer ring and you're just adding new features, and there's not that much space for re-architecting.
Yeah, because we're still following waterfall here in our plan, and we're getting a little bit more customer feedback, and then expanding our requirements and stuff. Yep. Yeah, comment?
Can you explain like a little bit more like how you use firewall control? Because wouldn't that be going from inner to outer instead of outer to inner, like you're
Oh, just sort of explaining how this is. This one. Yeah, I mean, so we've got all the stages here. And again, if we just think of these as like pieces of a pie,
yeah.
each time the pie is getting bigger as you move out.
Okay, so you're working from inner to outer.
Yeah.
Not the other way around.
Correct. Yeah.
Okay.
Yeah. Sorry. Inside to outside. Yeah. So we're going
I
around.
feel like direction.
Yeah. Although, I mean, I guess you could probably, I guess it's not shown here, work the opposite, where you say, okay, our iterations will get smaller over time, and then after 2 years, we're just done. You know, you could go either direction, actually. All right. So then we get to this one. Oh, these are getting fun names. Rational Unified Process. Okay. What's that? All right. So this is, we're getting pretty current here in 1999, but we're getting more iterative at this point. So we have 4 phases. They call them inception. So when you're, coming up with the ideas, elaboration. You're saying, all right, we got these ideas, but what are the requirements? And you're elaborating on it. Construction, where you're building things, and then the transition phase, where you're going to start thinking of some more new ideas. Now the way to think about this with the picture here, and this is just I captured this from the Udacity. This is just somebody's hand. His hand is always there. So ignore that. That's not part of the chart. But basically what this is showing is the height of these bars is showing how much time you're spending in each of these stages. So the idea is you're doing at various times all of the different things, meaning you're doing at one point all the requirements, all the analysis, all the implementation, all the testing. But if during that stage, if you're just doing a lot of the planning, you're doing less of the testing. Okay. So the width of these bars, so if we look at the very start here, inception, the very first one, let me circle with the laser pointer here. Inception here, we're doing a lot of the business modeling and sort of planning stuff, and maybe just a little tiny bit of testing, right? You write your first unit test, you make sure your code compiles, you have a main CPP, like the very basic stuff. But then as you go further and you start doing less planning, there's less to plan for, so yeah, you can start doing more coding. The plan's mostly there. Maybe there'll be some little changes, but that's the idea. And everybody's sort of working at this at the same time. Okay. So that's the idea with this process. So I would think of this one sort of like a startup in a way. Is maybe where you have something like this. You and a few friends, you're the engineer. You join with one of your friends who's the marketer. Another one of your friends who's the salesperson, another person who's the product manager, and some other business analyst, and you're all sort of maybe doing some of the requirements, but the engineers are sort of sitting there impatiently and saying, okay, let's start a little bit. They don't know the full plan, but they want to start going while the business people are sort of planning. And that would be maybe you and all of your friends from different disciplines working on a project. That would be a model where this is sort of used. Okay. We took our break. I'm going to keep moving us, and then maybe we'll take another one. But with that one, this idea of having multiple of these phases here, that actually brings us to our second software development life cycle sort of methodology or family, which is agile. Okay, we're getting into this idea of more iterative development. Okay, in short increments. Okay, so what is agile development? Well, we're moving away from waterfall. Okay, as we progress in time, but the idea is we favor individuals and activities over the processes and tools. Okay. So again, we're thinking about maybe an engineer's daily tasks and how they're doing stuff. We want working software over comprehensive documentation. This does not mean you don't write documentation. This just means you don't write the whole 200-page book about the software that you're going to write before you write the software. You want the working code, and then you fill in your Java docs or whatever your comments as you go along. We're collaborating with the customer and seeing what their needs are versus contract negotiation, right? And that was a big thing with the waterfall, where we said, okay, I'm negotiating a big government contract with NASA or the federal government or something, and these are the things we promise. So you have to deliver on them. It's written and signed in a contract versus what makes the customer happy, and that changes over time. Okay, so you can respond to a change versus following a very strict plan. Okay, and just a note on language, I guess. Agile is not a noun, so there's a little thing here. Do you agile? No, you don't say that. You say, I follow an agile development methodology. Alright, so here's a little visualization. Right, we've talked about waterfall, okay, where everything's sort of strictly happening in these chunks of time, one after the other. Iterative style of waterfall. But our agile processes, again, you can see multiple iterations here. Okay, maybe they're getting smaller, maybe they're the same size, but you have more of them here. All right. So pros and cons, just intuitively from agile development. What do folks think here? Yeah.
It seems like agile is optimal if you have a small number of stakeholders. It seems like the more departments or like more stakeholders you have to pull in, the harder it is to follow agile.
Yeah, right. If I have a lot of people, like if I bring in our startup example where it's just you and some friends, 5 people in a room working, you can move pretty swiftly versus if you're a massive, Intel or a big organization, and you really have to plan. Yeah. So that's agile, agility, able to move quickly. Yep.
But doesn't it mean that it will actually enable different teams to work simultaneously in different sets and then have more productivity?
So does it also mean you can have different teams moving on different parts of the project and have more
Productivity.
maybe, yeah. We'll have to figure out what more means. But yeah, I think there's more agility in that you can have different teams. You can change and say, hey, Mike, I think you're more valuable over here. You're going to go help those engineers and work on something the customer really wants. Yeah. Yeah.
I think it's more responsible to, or more responsive to the customer needs. And so it's like good, especially if the customer needs are always changing.
Yeah. So, customer needs, technology changes. Let me try to think of some examples. Okay, Netflix is one that comes to mind immediately. Hey, people aren't using DVDs anymore. Okay, we got to change. Okay, people want HD. It's like, okay, they want 4K. Different features that they might want. They want more international movies or whatever. We can sort of move quickly and adapt to what the customers are saying. We want more content of this. Okay, no problem. Yeah, I like those. Any cons of Agile? Yeah.
It can be pretty costly when you're bringing on contractors.
It can be what?
Costly when you're bringing on contractors.
Costly. Okay. Because, let's see.
If you're constantly iterating.
Oh, yeah. Okay, so if we're constantly iterating, and maybe we don't know when that's going to end, or and we bring in, some team of folks. I guess that's good for me though, because I do consulting, so I like it. There can be some costs, right? Especially, let me think about that. If it's like a short time frame, we could sort of adjust maybe, but maybe that's good and bad, right? We didn't plan up front. Right, with Waterfall, we just said, hey, it's going to cost $1 million. Versus Agile, we might get stuck and say, well, we need more people. And
You also may not build a good infrastructure if it's for an infrastructure project.
Okay, so yeah, we have to think about what our infrastructure is, and maybe if we're only thinking in short bursts, long-term infrastructure, maybe this isn't enough time to think about that. We can always stretch it or sort of build on it, but yeah, maybe that's not the right approach.
It seems like waterfall is more like intuitive, or so that like I could see where people say that they're following agile, but aren't actually following agile. Like it's some sort of waterfall. It is a real waterfall.
Very common.
So
Yeah.
I don't know. So maybe that's kind of a knock against agile if you can't actually follow it.
Yeah, so maybe we're thinking in agile, but inside of my head, I'm still thinking, hey, I'm building Duke Nukem Forever, and I'm still thinking about this massive project on these short stretches. Yeah, let's
I
see.
think it can also push developers to use more of adaptive kind of design patterns. Like once you have something and then you want to like change to another thing, they might want to take shortcut.
Okay, so this is on the pro side.
Maybe con side.
Oh, con side. Okay, so we're thinking, hey, we're just gonna use this design pattern. We're just gonna use singletons everywhere because that can get us out of trouble.
I mean, like, suppose you have something, right, and then there's a new need for something with the customer, so they might be prompted to use, like, a adapter pattern.
Oh, adapters everywhere? Yeah.
Like, make a very fast switch or, like, very fast solution.
Yeah, so we could get a bunch of code and sort of tech debt this way. Yeah.
Without
Yeah.
Yeah, your comment made me think of another pro or use case of agile where you don't accidentally use waterfall, you stick with agile. If your environment or your use case actually is volatile or agile, you have to follow it because your environment is changing.
Yeah.
Let's take like web standards, or like if you're linked up to something on the web and
Yeah.
Google changes something, you have no control.
Yeah.
So you have to follow agile.
Yeah. Right. So this happens. There are a couple of cases. I'm trying to remember the exact abbreviation, but if you're in Europe and you have to follow strict data privacy guidelines for what a company does with your data, right? And you don't really have any control over things that change like that from the government regulation. From if Google changes something, Apple is in a big court case right now against how much they can charge or how much profits they can take from developers on their app store, right? So things you don't have control over can be an advantage to sort of be agile, right? And say, all right, well, we're going to shift from Apple. We're not sort of locked into this game plan, okay? Let's see. So some pros and cons. Small updates. It sort of makes sense that we can work iterative. We don't have to predict everything up front, so the startup costs, we can sort of hit the ground running, right? Again, if you're going to do a hackathon or something, you don't need to spend the first, day planning everything. You just kind of start. It's for software development too to this point, and I think we've hit on this a little bit. It's sort of intuitive to be designing and developing things at the same time, maybe prototyping a little bit. Right, that's where that rational, unified process sort of was getting us to. And again, we want to, get things up and running fast to see, is it possible? You see this a lot in the gaming world, where you'll sort of release an early version of the game and get feedback. You'll see this in apps sometimes, right? You get a beta app of something. Sometimes that's good for the hype, right? It's like, oh, I got early access to, whatever platform. And that's kind of cool. So those are some pros. And some of these things started showing up, right, in other models with the iterative waterfall and stuff. But, we get some of these cons. Quality versus speed sort of has to be balanced. So are we adding a new feature every week? What does that do to our software? Do we need to do that? Could we get carried away? That's where your project managers help you. For applications where it just has to work, again going back to our banks, our airplanes, our cars, those kind of things, we probably don't want agile development. And again, this is one of the things where I'm sort of watching Tesla and seeing they're an interesting engineering company. right? The Tesla, I guess all of Elon Musk's stuff's kind of interesting to see how they sort of iterate, right? Whether it's SpaceX, Tesla, Neuralink, I don't know too much about, but AI stuff, but the Boring Company, digging tunnels, all these things. How many companies does this guy have? But if we need something to work day one, right? Are customers willing to sign up for a bank that's beta testing? Maybe not so much, right? There are some interesting banks coming out these days, but that's a different story. Yada Bank, has anyone heard of that? Where you get to play the lottery every time you deposit money in your savings account? All right, it'll be in the video. You can look it up. Healthcare startup. This one I put in here. I have this little note here. All right, you can sort of maybe start with waterfall and then switch to agile later. And someone kind of mentioned that about the healthcare startup, but that might be interesting to do. Get it working. Same thing with your banking app, and then maybe have new features. Maybe the dashboard is agile or something. All right, so we're getting close to the end here. So extreme programming. Sounds interesting. This is one part of agile. It's extreme. Cool. What's this? Where are we going? The 99. Okay, we haven't gotten into the 2000s yet. But this is one of the also ideas of sort of agile development, I guess, or getting in this space here. This is actually our author of Pragmatic Programming, Dave Thomas. So he talks about what it is. I think he's one of the sort of founders of this idea. But this is sort of the, I guess, software development life cycle of extreme programming, where you do some planning. Again, in the form of user stories. So here's some stories, and if you read these close, just says, I want a city object to hold a list of common locations, airports, theaters, etc. So you're just sort of writing what the customer wants, or somebody who cares about the software. Then you do the design, again, made up on the fly. The idea is use the KISS principle, keep it simple, silly. That's my PG version of it, I guess. And again, paper prototypes, these kind of things. And then you do some coding. And this is kind of cool because, and again, depending on where you've done your computer science programs, whether here or elsewhere, during the coding step, what's mandatory about extreme programming, what makes it extreme, is you do it in pairs. Okay, so there's always two people working on the same piece of code. I actually like that. It's kind of cool. Okay. And then, of course, you test. So you're trying to, of course, find errors. This is what we're going to talk about in 2 weeks' time. Maybe a little bit next week. And actually, this is a really important part. You'll sort of see where the arrows go. You often do as part of this a lot of your unit tests. And in some cases, the coding part is sort of test-driven development, where you write the tests first and then the code. Okay, and then you just increment. So throughout these various iterations, you might get a release out. Okay. All right. So there's a talk. This is from here's one of our authors again, Dave Thomas. And he gives this really bold title. It's called "Agile is Dead," but he's talking about what it is. So he says here, agility, what to do. Find out where you are, take small steps toward your goal, adjust your understanding based on what you learned, and you repeat. Makes sense. That's sort of how we learn things, taking small steps and so on. So, how to do it. He's got this other bold note. When faced with two or more alternatives that deliver roughly the same value, take the path that makes the future change easier. Okay, so you're planning a little bit for the future, and then just think about what delivers the customer the most value in the present. Okay. All right. So To kind of wrap this up, a little visualization here. This is sort of a classic waterfall versus agile, if you want to remember it. The waterfall design is like a really big cruise ship, or one of these warships that doesn't really, if you have to turn, you can't really turn very quickly. You're moving the whole ship at once, right? Versus, a speedboat. This would be something that's very agile. It's small, it's tiny, it can kind of move around quickly and turn and adjust as you need. But, here you're moving with the ocean, and that's it for it. All right, so, none of these rules are universal. It's kind of a funny lecture to give in the sense that, I can give you Bohm's law, which is a law or a guiding thing to think about where things are expensive. But whatever software you develop, you're going to have to choose one of these strategies and just think about what your trade-offs are, what really matters. So in that way, it makes sense to think about these things. Okay, so there's no best. Anytime someone tells you agile is best, well, you can challenge them. You can say, well, what about a bank? What about this thing? All right, so you'll have to sort of evolve or adapt your strategy as needed. All right, so with that, we'll have our in-class activities, so don't forget to do that. Of course, those are on the website. And I got to finish our Scrum where we started 2 hours ago or so. Anything unclear before we move to the lab? I'll introduce the lab, and then we'll break into lab mode or from there. Yeah, dude.
So what is something like test-driven development fit into all of this?
Yeah, sort of in the extreme programming realm here, where we're doing things very incrementally. That probably deserves its own slide. But basically the idea again is we can sort of flip these, write the test first and then code it. What do you think should happen? I guess that sort of falls into, and maybe that's part of planning. So I actually don't have a good figure for that. That could be agile or waterfall, honestly, depending on how you plan it. But yeah, that's, I think that's primarily something we try to enforce at Northeastern, test-driven development. Write your tests first. Those are most important, more important than the code. Think about the test you'd write. And that we'll get into, assignment 4, we'll see why it's really important. Yeah?
I'm still not sure how extreme programming is different than agile. It kind of looks agile. Like we are sending increments of software and then doing the same thing.
Yeah, for this, this is the main difference. So if I was going to ask you, or if you were going to sort of explain the difference, the pair programming portion, this idea that the coding is done together. But this is, right, each of these steps here, there is a loop here that you're sort of doing the iteration, and you just have some increment over time. So it's agile in that sense that it's incremental.
Basically adding more perspective in each stage.
And adding 2 people. Yep. Yeah. Definitely at the coding stage, but all those stages you'd be with somebody. I actually have done this. It was useful. I would recommend a first, maybe this. I mean, when you go on a first co-op or maybe a second one or whatever, sitting down with an engineer that you work with at some point and just saying, hey, can I work with you for 30 minutes, see how you work, what tools you're using. I think that can have a lot of value. That's why I like this extreme programming one, because I see new tools that people are using, how their workflow is. I think that's useful. If people want to, maybe I can just do a recording of me building mini paint. Then I have to forever retire that assignment, but it might be interesting just to see how I do it and record it. So feel free to request that at some point. Not today though. I guess it's due tonight or tomorrow.
A day or 2 ago.
I did move it to the 5th. I moved it around a couple of times.
Oh wait, you moved anything to do it?
Yes, I think to the 5th, maybe it's latest. So yeah, if you use your tokens, you can move them back to extend your assignment. You can get them back. And just because there are enough people wrestling with CMake, and I want to just provide a little bit more support there. Other questions? Retros-
Is that what, anywhere on Earth, the 5th?
Anywhere on Earth. Yep. Yeah. Yep. So yeah, there's still time. Alrighty. So just really quick, your lab. Let's see here. Repo for lab 4. You're going to be working on software development lifecycle. So we're taking a little step away from coding, and basically you're going to be doing the requirements analysis for the different things that you implemented in Minipaint. So the changing of the colors, the user interaction, changing the pixels, and it's tiny here, so let me make it a little bit bigger. Basically summarizing what the use cases are. Right, so we're taking a step back and planning a little bit to say, okay, what was involved, what system, should there be any error conditions? All right, and we ran into some in assignment 2. What happens if the mouse goes out of bounds? Well, we should probably handle that, right? We can't forget everything and just let the program segfault. Or maybe we can, but we have to decide, right, what that error condition is. Okay, how important things are. So that's the idea with Lab 4, getting a little bit of practice with this one. Alrighty. Yep. Oh, sure. All right. Let's see here. Okay, so we'll look over your use cases. I will just note some of these, depending on the feature that you're implementing, it won't make sense to have all of the use cases filled in. So it is okay if you have some that say not applicable or explain why it's not applicable. Okay, for each of these fields. Most of them you'll fill in, but sometimes it won't matter. All right, so that's for the lab. The homework will be also released sometime very soon. Other questions, comments? All right, if not, you're welcome to work on the lab here. I'm going to hang out for a bit. I'll handle other questions, and we'll see you next week. I'll see everybody next week.